let's start. Good luck, everyone.
Thank you. Good morning, everybody, and welcome to this morning's webinar from the British Romanian Chamber of Commerce. I'm Neil McGregor, the chair of the Chamber up until January, and I'm now Vice Chair for Corporate Governance and Relations with the British Chambers of Commerce. Now, it says up here, Bucharest and Sofia for the law firm, but in fact, I'm talking to you this morning from darkest Norfolk. So we really are covering everything between the UK and Romania and further afield. Now, this morning's webinar is extremely timely because you will not have failed to have noticed that there are problems with our neighbors to the east. And if you follow the website of the National Cybersecurity Center, you will notice the warnings about protecting against possible problems with black hat hackers attacking systems in our countries. Now, this morning's presentation is entitled How to Protect Against Ransomware, and it will be delivered by Extortion. We have Octavian and Peter, who are speaking for us this morning on this. A few words of administration. We are also going live on Facebook. Now, if you have questions, I'm sure there'll be many questions here. If you're joining us with Zoom, there is a chat box at the bottom of your screen with Q&A or chat, and that will be monitored during the call. And at the end of the presentation, Peter and Octavian will deal with the questions. If you're watching us on Facebook Live, please put your questions on the comments, and that's also going to be monitored. Usually, as I've mentioned, we find that our audience on Facebook is a multiple of the people joining us on Zoom. So that's how we're going to do it. I hope you have a very interesting and successful presentation. Peter, Octavian, we look forward to hearing from you. The floor is yours.
Thank you. Hi, everyone. My name is Octavian. I'm a pre-sales manager for Extortion. Also, I'm a Cisco and Tanix certified engineer. And together with Piotr, who is an extra great senior pre-sales engineer, we'll present to you this webinar. First, I would like to say a couple of things about Extortion. We are a growing company and we are focusing on two strategic directions. Direction is infrastructure with data center networking, cybersecurity backup, and disaster recovery solutions. Also, we are pioneers in hyper-convergent infrastructure in Romania, and we are promoting and implementing complex data centers projects both in the governmental and private sectors. The second direction is process automation and business intelligence. And to be more precise, we are developing RPA and BI solutions within the UiPath and Microsoft ecosystems. I would like also to take this opportunity to thank to BRCC for their good partnership and for their involvement and support in organizing this webinar. We can confidentially recommend joining the Chamber of Commerce for networking and social events and the business opportunities that comes with along this membership. So without no more further introduction, today we'll discuss about how to protect against ransomware attacks. As Neil said before, during this presentation, I will invite you to write all the questions in the chat, and that final Q&A session will respond to all of them. So, the agenda. This webinar was designed to raise the awareness of all users and to expose the majority of the most common threats, and to show how can you make your company better from the security point of view. I would like to start with a small history about ransomware and cybersecurity threats. Many years ago, the first malware that was it was created as a viruses, and it was created for the malware geek grid and not for money, as you may think. So their first creation was some kind of joke to make to mention on a computer girlfriend's name or to make some kind of joke display, but those days are long past. In our days, malware coding is just another business. Some attacks steal personal information that can be sold on the dark web, and others take control of computers that they can rent out for such things as distributed denial of services attack. Usually with ransomware, there are no buying and selling involved, and in most cases, ransomware goes straight for the cash, encrypting your critical files and demanding you to pay in order to get them back. It's true that your antivirus program should fend off ransomware, just as it is does with the other types of malware. But if it fails, even for a brief period, you are in serious trouble. So what is a ransomware? The word ransomware is a merging of terms ransom and software. The intended purpose is to prevent a person from accessing systems or files in exchange for a ransom. A ransomware is just a form of malware that is installed unnoticed on your device and prohibits access to your device or data. The difference between ransomware and normal malware is that the ransomware comes into direct contact with the users of the affected systems. The hacker takes control over the computer and demands a ransom as a recompense. As long as the victim does not pay for this ransom, the device will stay encrypted. And if the infected device is in a large network, such as a company, the malware can spread easily to the entire network and can easily encrypt all the devices on that network and can shut down your company. At the beginning, you will not know that you are hit by a ransomware attack because it is not showing the usual signs like when you are hit by malware. But he's encrypting ransomware is working in background, and he is aiming to complete his nasty mission before you notice his presence. Once the job is finished, it gets in your face, displaying instruction for how to pay the ransom and get your files back. Today, the most typically request from the ransom is the electronic payment or cryptocurrency, and the most popular choice is, of course, Bitcoin. So, is ransomware a virus? The answer is no. Ransomware is not a virus. Although viruses and ransomware are both malwares, they are very different. Viruses only infect data and replicate it themselves, and on the other hand, the ransomware encrypts the files and are waiting for a ransom. So how does ransomware work? A ransomware attack is a multi-step process, and if you have the proper defenses in place at the various steps of the attack, the impact can be greatly reduced. There are 5 steps of a ransomware attack. First is delivery and exploit. Here, the ransomware is delivered through certain mechanism, for example, phishing, and finds a vulnerability or a victim to attack. Second step is install and disarm. Here, the ransomware is installing by itself and lower the security posters of the victim machine. Step is occupy and encrypt. Here, the ransomware is establishing a communication with the command and the control servers, and he's encrypting your data, files, and map drivers. The fourth step is the demanding of the ransom. Here, when the users are trying to access their files, they are alerted that their data have been encrypted and they need to pay an amount of money in order to recover them. And the final step is decryption. After the payment was made, a decryption key will be provided for you by the attacker. There are 2 main types of ransomware. First type is crypto ransomware, and crypto ransomwares that are encrypting files or specific programs to block access to particular softwares. In this scenario, users can still have access, but they are locked out of the encrypted programs or files. And the second type is the local ransom. Local ransom that refers to an infection that locks access to a device or systems and is making all the system's components to be inaccessible. But how does the ransomware work and how he spread? Ransomware works by infecting a system and is limiting access to its programs or files, as I said before. Ransomware can infect a system through multiple channels. One of these channels is RDP. Remote Desktop Protocols, or RDP, is a powerful tool that enables remote control over the local machine. It's something similar with TeamViewer. However, it's recently become the main target for the ransomware attack. The reason that it became the main target is the pandemic, because during the pandemic, millions of workers had made the transition from make the transition to working to home. And many of the devices used to remote work were rapidly purchased or and configured. And this means that you have also more room for errors in RDP implementations, and also you have more instances of RDP that could be vulnerable to malicious actors. Also, you have the malicious URL. This is a link that is created with the purpose of promoting scams, attacks, and frauds. By clicking on the infected URL, you can download the ransomware, a virus, a Trojan, or another type of malware that will compromise your machine or even your network, and in your case, will compromise your company. Another type is malvertising or malicious advertising. This is a relatively new cyber attack technique that injects malicious code within the digital add-ons. They are hard to be detected by both internet users and publishers. These infected ads are usually served to consumers through legitimate advertising networks. And because ads are displayed to all websites visitors, virtually every page viewer is at risk of infections. Once clicked by a website visitor, the corrupted code within the ad will be installed in the malicious software and will spread on. Also, we have the spam email. Most often, ransomware is delivered via spam that is opened by a local user. When the local user are clicking on the corrupted file, the ransomware is downloaded to their system and he will be installed in the background without your notice. And finally, we also have the social engineering. The hackers gain passwords and other information to help access these systems and to plant ransomware. Most often, ransomware is an executable file that often tries to masquerade as a harmless in a zip folder or by impersonating a legitimate file. Basic ransomware requires human action, while other more sophisticated ransomware attacks are able to spread without any human intervention. Once a machine is attacked by ransomware, ransomware begins its work encrypting data to make it inaccessible or removing the user's account data. Ransomware is now the fastest growing and one of the most damaging type of cyber crimes. There are several types of cyber attacks, like phishing. This is a type of attack that involves sending a fraudulent message in an attempt to get the recipient to provide sensitive information such as password, credentials. Also, we have malware, which involves using viruses, spyware, or other malicious software to steal information. We have denial of services or distributed denial of services, attacks that denies access to systems, creating business downtimes. And of course, we have ransomware, where the data is stolen and is only given back when you pay the ransom. However, this data typically becomes available even on the dark web, regardless if the payment is made or not. According to Sophos, the average bill for recovering from a ransomware attack, including downtime, people hours, device costs, network costs, loss opportunities, and ransom paid, was around $1.85 million in 2021. Downtime. I mentioned downtime before. The downtime is resulting from ransomware, incredibly disruptive, and not just for the companies themselves. For example, the Colonial Pipeline attack shut down gasoline services to almost half of the US East Coast for 6 days. It involves replacing all systems and recovering from functionality and operations. Also, we have people hours. While Colonial restored their services after 6 days, their CEO, Joseph Blount, testified before US Congress more than a month after the attack that the recovery was still ongoing. So we have a large period of time and a lot of resources ongoing. Also, one of the realities of being attacked by ransomware is that it makes business a target for repeat attacks. Hackers don't always keep their promises when companies pay ransoms. In fact, paying ransom lets cyber criminals know that you are an easy mark. We have seen reports of repeated attacks, either because company already demonstrated the willingness to pay, or because the vulnerability that allowed hackers access to systems remained susceptible to be exploited. And finally, you have lost reputation and lost business. If a company is jeopardizing their reputation and ability to develop business, any company that had make this thing will lose their customer trust, and they will also lose money at the final point. About some statistics, according to AV-Test in March 2020, the total number of new malware detection worldwide was 677 million programs. According to an annual report of global cybersecurity, there were a total of 304 million ransomware attacks worldwide in 2020, and this was a 62 increased by the year before, and the second highest figure since 2016. Also, the statistics shows that how ransomware started to explode. If in 2015 we had ransomware attacks with rewards around $325 million, the report for 2021 was $20 billion, and it is predicted that until 2031, this amount will be 13 times larger than what we had last year. In terms of attack, if in 2021 we had around one attack at every 11 seconds, by 2031 we'll have an attack at every 2 seconds. So basically it will be 6 times larger. Prediction for cybersecurity ventures in at even bleaker pictures, and they are putting worldwide ransomware damages in the hundreds of thousands of billions dollars by the end of 2021. According to CloudWarsNet, this graphic is showing us how companies recovered their data after a ransomware attack. Basically, 32% of the affected companies choose the payment method. This is a thing that is not 100% moral or legal. 8% are choosing other recovery methods, while 3% of them are choosing not to recover their data. But still, a large number of the companies, and from this graphic you can see that is 57%, have a strategic backup recovery, a recovery that cannot be hacked, and you can use it to keep your data safe. This means that instead of days, weeks, or months, you can have your data recovered as soon as possible. The beauty of this method is that you can be attacked again and again, and every time you can restore your data and you can ensure your business continuity without any major impact. But more about this method we'll discuss in the second part of this presentation. Some recent attacks. In 2021, several high-profile companies were victims of costly cyber attacks. One of them was CNA Financial, who paid ransomware hackers around $40 million to decrypt part of their digital infrastructure, from which they locked the company out of. Another recent attack that I've already mentioned is the Colonial Pipeline. The cyber criminals targeted the Colonial Pipeline computer systems, and they stole nearly 100 gigabytes of data and impacting the company billings operations. The Colonial Pipeline paid the Bitcoin ransom of around $4.4 million, but the more significant impact was on the wider society, because the ransomware had affected the supply and the cost of the gas, and the hackers had broken through the ordinary people everyday experience. Another example is CISA. Victims received a ransom note informing that their files have been encrypted. The note said users could retrieve their files by purchasing the $45,000 decrypting software, available only in cryptocurrency. The attack directly affected at least 60 firms, and it had downstream consequences for at least 1,500 companies. Also, we have Vir Group, who faced $55 million lost profits following the ransomware attack. The attack to Vir Group statement, the incident, which occurred in early September 2021, they forced the company to shut down its IT systems, the enterprise resources planning operations, and the engineering application. Another big example is NVIDIA. After they was attacked, they wanted to hack back, and NVIDIA installed ransomware on the perpetrator's own machines, but appeared not to solve its problem by doing so. NVIDIA was targeted by the ransomware group, which stole the company's source code, including a proprietary hash rate limit that reduced the usefulness of NVIDIA chips for cryptocurrency mining. In their attempt to safeguard their intellectual property, NVIDIA hired security experts to locate the attackers' infrastructures and target it with a retaliatory ransomware strike. While the revenge attack succeeded in the infected hackers' computers, an act which perhaps ironically led the group to be labeled as criminals, NVIDIA failed to retrieve its data, and the group had backed it up. So in exchange for keeping NVIDIA data private, the hackers demand the company publishing its GPU drivers as an open source. And in addition for this, of course, they ask to paying in a cryptocurrency ransom. Some top ransomware attack trends. As the cyber threats landscape continue to evolve, a few trends can be seen in the ongoing rise of ransomware attack. We have the supply chain attack. This is the greatest concern in software supply chain attack. Software supply chains are particularly vulnerable because modern software is not written from the scratch. And today, the average software project has 203 dependencies. Also, we have the rise of the double extortion. In the year past, ransomware was mainly accomplished by single extortion, but where the attacker by single extortions where the attackers encrypted an organization data and demand a ransom in exchange for a decryption key. But now ransomware groups are exfiltering victims' data to a new off-site location before encrypting, and then threatening to leak out, publish the data if not a ransomware is if not a ransom is received. Also, we have ransomware as a service. This means that while the home users were once the targeted for the ransomware attacks, threat actors today are targeting a large enterprise network with more frequency. As a result, the evolving of ransomware as a services, or RAS, has gained increasing traction. Ransomware as a service is a type of pay-for-use malware that allows cyber criminals to purchase ransomware tools and to have already been developed in order to carry out a large-scale ransomware attack. We have also some ransomware kits that are allowing affiliates lacking of skill or lacking of time to develop their own ransomware variant and to be up and running quickly and affordably. These kits may you can buy them from the dark web, as you can buy from, I don't know, Amazon or Emag. As you buy your own cell phone, you can buy these kits. And these kits may contain 24/7 support, bundles of, or even you even have users review forums and other features identical to those offered by a legitimate software as a service provider. So in the next slide, we'll see how to defend and protect against ransomware. We'll see some best practices. There are a number of steps that you can take in proactive ransomware protections. First step is to backing up your files regularly and frequently, having a diligent data backup process in place, and to limit the damage caused by a ransomware attack significantly. You need to have complete operating systems and any software updates as soon as possible. Software updates typically contain patches for security vulnerabilities and should be installed as soon as possible from their availability. If you can, it will be good to enable the automatic update process. Also, do not click on any emails or links from unconfirmed sources. Emails is a very popular medium for phishing attacks that distributed ransomware or other malware via infected attachments or links to malicious website. Never give out password details and avoid discussing personal information with unverified callers. Also, you can disable your autorun for all mounted devices. By disabling autorun, will prevent malware from being able to spread autonomously. And this is an important step in containing malware should an infection occur. Also, disable antivirus solutions and the firewalls can help to block the malwares. For additional protection, companies should consider endpoint detections and response and advanced threat protection solutions to improve ransomware detections and blocking capabilities. Also, the macro content from Microsoft Office applications can be disabled. By disabling macros, this thing can help you to prevent compromises even if an infected file is opened by an user. If you don't need it, you need it will be good to disable the remote desktop connections when it is possible. By default, this RDP is not coming enabled, but it will be good to check. Also, you only need to log in as an administrator as long as it is necessary to limit administrator privileges and the use of the admin accounts whenever possible to ensure that the user have been compromised. It isn't inadvertising granting administrative privileges to an attacker or someone who gain access to their account. Deploy security software to boost ransomware protections. And finally, for the end users and the organizations, awareness and educations are key for protecting against ransomware attacks. So by educating yourself and your users on basic protection practices and keeping up with current security threats, you can mitigate the risk of the ransomware attack and keep data safe. Make sure that you have backups and any important or sensitive data and systems. Practice your restore motions in the event of a ransomware strike. Limit access to backups, and as ransomware gangs often target backup files to cripple your ability to restore. However, keep in mind that backups cannot help in case where the ransomware actors are also exfiltrated the data to their own servers, and then they threats to release the data publicly unless you pay a ransom. For the backup solution, the ideal thing is an appliance, something like Exagrid, for example. Another question is that should I pay for the ransom? Well, the expert's answer is no. Experts and investigating authorities advise against paying the ransom. Often the data is not decrypted despite payments, and the computer is still not usable. Therefore, anti-ransomware solutions should rather be used, and preventative measures should be taken so that paying ransom does not become an option in the first place. As more ransomware victims hit the experts, advise not to pay the ransom. The rate of total ransomware attacks keeps rising, and with criminal turning their sights on vertical like healthcare or law enforcement, that tends to be more willing to pay because of the life and death consequences that can result from this computer downtime in their fields. So one question will rise: how do I get back my old data? What is ransomware recovery? Basically, ransomware data recovery is a process that is followed to bring IT systems back online after a ransomware attack. Recovery can be simple. It can follow many of the existing disaster recovery processes that you have today. In the data protection space, there is a huge focus on recovery, especially recovering encrypted VMs from backup. While this is a big part of the ransomware recovery, there are also wider impacts to the rest of your IT environment. Forensic analysis is conducted as part of the cybersecurity incident response to determine how the ransomware goes into the environment and what system it is infected. At this point, steps can be taken, and you can eradicate the ransomware, remove the vulnerabilities that allowed the hackers attack, and restore the impact systems. even if I would like also to say that even if the ransomware gets past your antiviruses, chances are good that within a short while an antivirus update will clear the attackers from your systems. But the problem is, of course, that removing the ransomware doesn't give back your file. The only reliable guaranteed recovery is maintaining a backup of your important files. And there are a number of different approaches to accomplish this goal, but about this, I will let Piotr to explain more in detail. Piotr?
Yeah, just please stop sharing the screen. I will share mine. Thanks. Hello, everyone. I'm Piotr Kasiewicz. I'm based in Warsaw, Poland, and I will tell you a little bit more about the last stand in terms of restoring data after ransomware attack. Yeah, please let me share my screen. Just a second, some technical issues with Zoom. Octavian, are you still sharing the screen? I mean, something that I need to click to share?
I've stopped the sharing.
Okay. Okay, I do have something wrong with my PowerPoint. So let me just close it and open it again. Okay, should be okay now. I believe you can see my screen already. Sorry for this short break. Octavian, can you confirm that you can see my screen?
Yes. Yes.
Very good. So thanks for this introduction, a very interesting one. The main outcome of your presentation for me is that basically even the antivirus software can be compromised, even the backup software can be compromised. So what we should think about when we are creating a new or modifying the backup system, first thing, should it be the backup speed? Yeah, for sure. But with modern backup applications, you have all the time in the world to do backup because backup can be done online. So no one will just stand upon you with angry face asking you to bring back data or backup data as soon as possible, because backup can be done online and you don't have to stop the production environment to do backup. So the backup speed isn't the case anymore. The restore speed is the case in these times after ransomware attack, because after the ransomware attack, you have to bring back the whole environment at once. The other thing is the cost of the single terabyte of backup. Is it really important? Maybe, maybe not. You will see after my presentation, we can talk about that afterwards. And a very important thing called air gap. So the possibility of physically diverting the data from the backup system to the other medium. All of them are important, and all of them can be achieved using different solutions and different architectures, different devices. But we can also use something else. When we plan to do a backup application with the whole backup environment, we can choose between two main approaches, which is straight disk. So just a bunch of disks with the RAID 6 or something like that, without any intelligence, without the duplication, but basically very cheap. And the pro in this approach is that the disk arrays are fast because they are not doing compression, the duplication, they have no intelligence. They are fast for backups and fast for restores. We can also use something called the duplication appliances or the duplicators. And as you probably know, the duplication is a process of storing the blocks of data just once instead of duplicating them for a lot of times. So we can lower the disk usage. Yeah, that's it. From the cons perspective, the storage array or disk array can be very costly because for each 1 terabyte of data that you have to protect, if you have the procedure to store the data for a longer period of time, like you are storing the incrementals for weeks, like some weekly fulls, some monthly fulls, or even yearly fulls, from 1 terabyte of backup data, after 1 year, you can have 15 terabytes of data of stored backups, stored full backups. So this storage grows and grows, and it costs more and more. And that's why some of the architectures are using those deduplicators. But the process of inline deduplication, which, as the name says, goes inline during the backup session or restore session, takes a lot of resources because data, the backup data that comes from any backup application has to be cut to pieces, these blocks. These blocks has to be computed by the hash, and those hashes has to be compared between each other. Then goes something called bucketing, compression, and so on, so on. And all of this has to be done during the backup session. So it takes a lot of resources and it makes the backup slower. From the other hand, if you want to restore data, you have to rehydrate them, which basically is the same but in the other way. So if you need to restore a lot of data from the duplicates, it can take a while. And from our perspective, from our experience, it can take days. So just try to imagine the situation when the whole environment was hit by ransomware and you have to bring back all the data, all the databases, all the VMs and so on. And you have to wait like 3 days before you can do that because the backup or restore in this case is so slow. So this is why the duplicators, inline duplicators were kind of common for past few years, like 10 years or something, but in the times of ransomware, they are going less and less useful because of the restore speeds. The third thing that you have to consider when you build architecture of backup is the scaling. Most of the disk arrays and all of the inline duplicators has something called scale-up architecture, which is traditional architecture based on controllers or storage processors, whatever they are called, and disk shelves. So you can have 2 approaches when you are buying such a thing. You can first buy a smaller controllers, but in the lifetime of the data, if the environment grows and grows, they become not really performing anymore. So you have to replace them, and this is called forklift upgrade. You have to replace them for the more performant. You can also buy the big, very fast controllers, but for few years on the beginning, you just have information that you paid for something that you are not using because there are not so much data yet to be processed. So you paid like thousands of dollars for something that is not used. The better approach is to have something called scale-out architecture, which means that the device you are buying has its own processors, its own disks, its own memory, and its own cards. So with every terabyte or with every pack of terabyte that you are buying for the backup system, you are also expanding performance of the backup system. And that keeps you on the same level with the backup and restore all the time. And it doesn't matter if the environment has 10 terabytes or 10 petabytes, because it's always performing the same, and the time of backup and time and restore is always the same. So going back to these disk shelves and processors, they are fast for backups, fast for restores, but basically the disk arrays are expensive for long retention times, and they are using a lot of disks. They cannot be scaled, and they need these forklift upgrades if you need to improve the performance. From the perspective of the duplicator, inline duplicator, they are slow. They are slow for backups. They are even more slow for restores. They are not scalable, and also they need forklift upgrades to be upgraded to the better version. So is there any possibility to use the best of those two worlds to make the backup application and backup environment performing well? Yeah, and this is called tiered backup storage appliances. And they are basically done logically by using two tiers of storage. The first tier, called performance tier or disk landing zone, is the tier that is not deduplicated. So the data comes there and goes back from the backup application and to the backup application exactly as the backup application wrote them, without any deduplication, compression. So this tier is made for fast backups and even faster restores, because no intelligence is involved. And in most cases, we plan this performance tier to keep at least one full backup, so you can always restore the whole environment from this undeduplicated backup. Underneath, we have this retention repository, which has a very deep and very thorough deduplication. And the only thing that can move data between this performance tier and this retention repository is the internal engine of the device, which means that you can access this landing zone from the perspective of the backup system, for example, Commvault, Vim, or whatever system you are using, because it serves data by using NFS or CIFS. It's just easy to be accessed from network. And due to that, the backup system can easily read and write data on this landing zone by just using some user and password and some permissions. From the other hand, this retention repository is non-network facing. No one can access it, no one can change it, no one can tamper with it. And the data in this retention repository are very deeply deduplicated, because the duplication doesn't have any impact on the process of doing backup or restore. During the backup or restore, the appliance just does nothing on the landing zone. And after the backup is finished, so after the IOPS are stopped, after the backup job is finished, the duplication starts, and the retention repository is filled with the duplicates from the landing zone. So after this process, you have two different copies on this appliance. First, undeduplicated in the landing zone, and second, after the duplication, in the retention repository. So already two copies. First, the undeduplicated, and second, the duplicated. And basing on this architecture, this kind of appliance, this kind of tiered backup storage appliance, can provide you with the last stand for the data restoration after something happens with the backup system and production system and all the other systems in the architecture. Because it's kind of easy to understand. If you have the primary storage, production storage, and some backup application that reads data from primary storage and puts those data on the performance tier or landing zone, this is basically just files, because such kind of appliance is using NFS or CIFS. So the backup application has to put files in this performance tier. And if there are just files, then can be modified, deleted, or altered in any other way if you just have a permission. And as Octavian said before, a lot of attacks, ransomware attacks, or even different hacker attacks are targeted to hit the backup application. So the user, so the organization has no backup to restore. So basically, the organization has a big problem and has to pay ransom. In such device as the tiered backup storage appliance, you have always the second copy of the data, second copy of backups in the deduplicated form on this retention tier that cannot be anyhow accessed from the external network. Even this backup appliance administrator cannot alter them. So if something happens to these backups in performance tier, like they are encrypted or deleted, with just a few clicks, like really 5 clicks or something like that, and few minutes after that, data from deduplicates from this retention tier can be presented to the backup application, and the whole state of the share, NFS or CIFS share that the application was using, can be brought back to the state from 1 to 30 days before, and it can be brought back for any completed backup session during those 30 days. So you can bring your data back for the backup application, like exactly from the moment before the ransomware hit you. And as this is something that is using NFS or CIFS, it's very useful for different backup application. You can use any application that can write data to NFS or CIFS, or you can use any application that dumps data to NFS or CIFS. So you don't even have to involve like some backup application, because for example, if you just have Oracle and the big databases of Oracle, you can use Airman dumps to route those data to NFS, and they will be kept safe, deduplicated, and kept for the time that you want them to be kept. So this tiered backup storage appliance as the last point of defense in the backup architecture can give you storage savings because of the data deduplication, replication savings because of the same data deduplication. It can be as fast as straight disk because the data is not deduplicated during the backup or restore session. You can keep your SLAs on the same level because you don't have to wait for the data to be refrigerated if you need to bring them back. You have included ransomware recovery protection because of this retention repository and the fact that it's not accessible from external network. And you can keep the backup windows with the same length if you scale out your architecture because of the linear scaling, and each terabyte that you are adding to the architecture gives you another performance. So just ask us about these tier backup appliances. And if you have any questions, just go ahead, shoot. I can answer them right now. Yeah, the first question is the deduplication starts after the backup is finished, or they are going in parallel? In such appliances, the deduplication starts as soon as the engine has enough resources to use. So if the backup still goes, but the appliance still has some resources to use for the duplication, it can start in parallel. So it still has no impact on the backup speed because it's just using the resources that are available. Yeah, so this is called adaptative deduplication. If there is a big backup and no resources are available for the duplication, it will start after the backup is finished. Yeah, can you run applications or VM from the landing zone? Yeah, basically, of course, you can do that. As the data is not deduplicated, the applications or VMs can be run like from the straight disks. So with the full performance of the data that has to be read. So yeah, the basic answer is yes, of course, you should even do that. Most of the backup vendors are recommending to use undeduplicated storage as the source of the VMs or applications running from backup. Can it be less costly to pay the attackers the ransom rather than paying for the damages caused by a ransomware attack? That's the question for Octavian, I suppose, because this is the part of his presentation. Octavian, you there?
Yes, I'm here. I just read it now. I believe that the better way is to say that is less costly to buy your equipment and to improve your security than to give it back to the attackers. I believe this is how we need to see the things. We need to improve our security in order to not have this kind of security problems in the future. So this will be my final answer for this.
Yeah, I'm not sure about the Romania, but I can speak about Poland, where am I based. And last year, we have more than 250 attacks of ransomware here in Poland, at least the ones that were reported to this national security center of ours. And the average ransom request was more than 200 case of USD. So more than $200,000. And I'm not sure if paying average ransom of $200,000 is less expensive than preparing the organization for such events. I don't think so.
And also, you have no promises that will give your data. Do you give the encryption key or your data back?
Yeah, this is true.
Because I believe that more than half of the paid ransom was not delivered, the encryption key, or if the decryption key was delivered, it was the wrong key or something wrong.
It wasn't working. Yeah, I heard about such cases.
Working, or the data was corrupted or things like that. So
if I could just add there, we have a history in the UK. After the Romans left, we had many raids for ransom by Viking people from Scandinavia and Denmark, and they extorted a payment tax called the Dane Geld. And we have a saying: once you've paid the Dane Geld, you'll never get rid of the Dane. So we like them very much nowadays, but it may even actually be illegal because you're paying someone who's committing a crime. So I think the advice would be, don't pay.
Yeah. From the other hand, I'm reading some kind of web page in dark web, which is a community of ransomwares, let's say. And you know how they call themselves? It's a post-paid pen testers.
One way of looking at it. Hard to budget for that, though, if you're a business.
Do all countries have regulations regarding ransomware? I don't think so.
I don't think so.
Basic answer. Some of the countries does have some regulations, like the Great Britain, for example, and paying ransom is a crime there, but not in Poland, for example. Also, from what I know, the US is having the same mentality. For them, is like just a normal terrorist. Yeah. But they are not negotiating with terrorists, I suppose. So yeah, it's the same principle. I've heard that there are companies like middlemen in such negotiations. So you are just paying for not for the ransom, you are paying for consultations for some company, and this company pays ransom underneath and bring you the encryption key back.
I think that is highly suspect. But...
yeah, it is. Exactly, it is, for sure.
Okay.
Well, we have 40 people watching us, or more than 40, I think, on Facebook. So welcome to all of you on Facebook. Any other questions? We're coming up to the hour.
Okay.
No,
About this landing zone part of the backup appliance, how you can keep data on landing zone? Is it a fee for protocol or data retention? It's completely transparent to the backup application. The backup application thinks that all the data is in the landing zone, and the appliance engine underneath is just moving data from landing zone to the retention repository, leaving just the stubs, like links to the original data. Yeah, basically that's it.
I think we'll need to call a halt there because we're on the hour.
Yep.
We've had a lot of interesting questions. Thank you for all of your questions. And thank you, Octavian and Piotr, for your very interesting presentation.
Thank you also.
I think I would say it's similar, if you wish, to bribery and corruption. When anyone can extort money from you for doing what should happen or shouldn't happen, I'd say it's a similar kind of thing. So I do really hope that people will find what you've said useful and make sure that there is a way of stopping this kind of extortion. Thank you very much indeed. Thank you all for taking part.
It was a pleasure.
Can I just mention our next chamber event, which will be the forum, and just I find details of that. I will put details into the chat box. This will take place on the 7th of April from 9 in the morning until 5 in the afternoon at the Marmaros Hotel in Bucharest. And so your chance to have a face-to-face event there. So in the chat, you will have the link there, which I hope you can all see. Now that spring is coming, I hope to get back to some face-to-face events such as this. You'll have seen we had a really successful event at the House of Commons in London recently, and you'll be seeing us doing a lot more. So I think now we're going to have a very interesting year, now that we've had the disruption, if you wish, of what's happening next door. Plus, we're hopefully getting out of the pandemic, but also we've got used to working with the good things in the pandemic and working remotely. Thank you very much again for taking part. I wish you all success in your businesses and have a good rest of the day. Thank you very much indeed.
Thank you.
Thank you. Goodbye.
Bye.